Okay, guys. So we're starting our first session on blended learning. We're going to talk about functions. So the first half of AFM is all about probability and all of that fun stuff. Now we get into functions. Functions is more of your very practical math. Probability is more the real world application. Okay, so I know some of you are like, oh, that's boring, but I'm going to do my best to make it as applicable as possible and as fun as possible. So got a lot to cover, and we're going to jump right in. We're going to end up going over all different types of functions. Well, before we talk about all the different types, you need to know what a function is. So let's write a definition for a function. Okay? A function is just a graph, okay, of a dependent and independent variable. I-N-D-E-P-E-N-D-E-N-T. Is it bad that I really have to do that to spell it? Independent variable. So you need to know what those are, okay? So that's a very mathy definition of a function. So you need to know what a dependent and independent variable are. So dependent, it's going to be kind of dependent, self-explanatory. It is the letter or the variable that is, I'm not going to say dependent because that's in the word, is derived from the other letter. And independent, I'll put that below, I think you can still see that, is the variable for the letter that stands by itself or stands alone. Okay? So those are my two dependent, independent variable. As you know, star that, star that, star that. Okay? So we're talking about these functions. Now you know what a function looks like. If it's a graph, okay, what's the graph of? When a function is graphed on a x and y axis, those become your variables. All right? The x variable, so here's my axis, x and y. X is always, and I'm going to say always, not when you're graphing, it is always the independent variable. Put IV, independent variable. Y, therefore, is what? My dv, my dependent variable. Okay? So when I graph a function, you should have known this, but this, right here, is very wacky looking, right? It can be wacky looking. That's one graph. Now I'm going to draw another graph. Here's another graph. Not as wacky looking, right? So it's just a C, big old C. One of these is a function, one of them is not. You have an entire worksheet about this, and hopefully I just posted it at the bottom if I did my editing right. But the way to see if something is a function is not whether or not it looks crazy or not, but it's called the vertical line test. So, a vertical line goes straight up and down. If you had a vertical line, I'm going to use this ruler as a vertical line, and I place it on my graph right here, okay? How many times does my vertical line, my ruler, touch my graph? Now my graph is not the x and y axis. It's just what I've actually graphed. So it's just this squiggly line, okay? So I touch right there. Do I touch anywhere else down here or anywhere else up there? No, I just touch it once. If I was to do that all the way down through here, touch it once, 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 once. Would I ever touch it twice on this first graph with my squiggly line? No, I only touch it once. So I'm going to write the vertical line test. Vertical line test. So, what this says is if you touch once, it's a line. Or sorry, it's a function. If you touch once, it's a function. If you touch more than once, not a function. 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 And my battery is about to, I'll make sure you're still recording. And I am. Beautiful. Okay, so my first one, is this guy a function? Yes, I only touched it once. However, look at my C. Is this a function? Boom, right here. If I put this, my vertical line right here, how many times do I touch that graph of that C? Touch it once here, and I touch it once there. Is that more than once? Yes, so it is not a vertical, so it's not a function. So function, not a function. That is a whole worksheet, and it's really easy. Now, another way to graph things is you need using your x's and y's, right? Like if I told you to graph the point 3, 4. There, I'll just make a new one. If I told you to graph the point 3, 4 on this bad boy, okay? So I want you to graph 3, 4. Well, you know the first one's your x, your second one's your y. This is my x-axis and my y-axis. I would go over 3, positive 3, so 1, 2, 3, and up 4. 1, 2, 3, 4. Put a dot. Okay? So that's easy enough. Now, if I tell you that what if I give you a table of points? Okay? And I'm asking you if that table is a function. Well, we're going to see something. Let me erase that. So that's obviously how to graph a point, but we're going to graph this. So I give you a table of x's and y's. And I tell you to graph -2, 3, 1, 7, 2, 3, 4, -5, and -2, 0. Okay, we're going to graph those points and see if that is a function. So I now have my points. And I'm kind of working backwards. So I gave you the graph, and now I'm giving you a table, and the next thing I'm going to give you is an equation. So we're working backwards for a reason. So I want you to see what makes something a function or not. Do I repeat any x's? I do. I repeat x's, -2, right? I repeat those. Do I repeat any y's? I do. 3's. So what I'm just going to, I want you to notice that, or as we work down, we're going to see if it ever stops being a function. Remember how to check a function? The vertical line test. So let's graph this. -2, 3. I need my points. -1, -2, 3. Is it still a function? Well, yeah, I've only got one dot. Okay. 1, 7. Okay. Let's go to 1 up to 7. Is that still a function? If I put a vertical line, would I only touch it once? Yes, I would. Okay. Let's go to 2, 3. So 1, 2, up, 1, 2, 3. Okay. It's steep, but would I only touch it once? Yes, I still want to touch it once. So we're good, good, good. Have I repeated anything? Yes, I repeated my y's. Right? I repeated my y's. These are the same. So, my question is, can you repeat y's and it still be a function? Yes. You can repeat y's and still have a function. Is that my door? I think. You can repeat y's and still have a function. So we're going to keep graphing and see if it ever stops being a function. So we've got these three. Let's graph the next one. 4, -5. 1, 2, 3, 4, down. Let's make that line. 1, 2, 3, 4, 5. Okay, is this still a function? Yes. Still got a vertical line. It's kind of weird looking. Still a function. Okay, let's graph my last one. -2, 0. -1, -2. Okay, does it look crazy? No, but is it a function? If I put a line at -2, how many times do I touch it? Well, I definitely touch it at the points where I put a point, right? So that's at least twice. But technically, I touch it every single one of these little dots. So I touch it a million different times. So what you need to see is you can repeat y's and still have a function. But if you repeat x's, it is not a function. Okay? So now I've showed you how to do it from a graph. Now I've showed you how to do it from a table. And the third thing I'm going to show you how to do it from an equation. Right? So this is all showing you how to say if something is a function or not. Okay, I'm erasing that. Now thirdly and lastly, I'm going to make several videos, kind of break this stuff up. This one's just about functions. My third one is this. Okay? How to do it from an equation. So let's say I've got y equals 2x plus 3x squared minus 7 all over 2. We're going to see if that's a function. Okay? And I want to know if it is a function between a certain amount of points. So let's say I want to know, is this a function between x equals negative 3 and x equals 0? Is it a function between there? Okay, so I'm going to plug in and see if anything repeats. Actually, let's do y's. No, we'll do x's. So I'm going to plug in. So I've got to get this table, right? Got to get the table. So let's plug in. Negative 3 for x. This is what's important. This is the same as you used to do when you were probably in middle school. It's plug and chug. Okay, everybody says plug and chug. So I'm plugging this negative 3 in for x. So I get y equals 2 times negative 3 plus 3 times negative 3 squared minus 7 all over 2. Okay? I'm going to do all this math in my head. Ready, set, go. Negative 6 plus 9 times 3, negative 27 is negative 33 minus 7 is negative 39 divided by 2. Y equals negative 19.5. Okay? So when x is negative 3, y is negative 19.5. Alright? Now, think about what I told you my dependent and independent variables are. If y is dependent, like I said it always is, and x is independent, can you plug any x in and figure out a y? Yes. That means it's independent. It stands by itself. However, you can't plug in a y, right? You don't like plug in a y and then figure out x. No, it doesn't work that way. You plug in the x, do the math, and it spits out a y. See, I plugged in my x, I did my math, and it spit out what is left. Y equals a number. That's why y is dependent, because it depends on what your x is. Okay, side note. Now I'm going to plug in my negative 2. Okay, because I'm asking between negative 3 and 0. So I'm going to do negative 3, negative 2, negative 1, and 0. And I need to see this to see if it's functioning or not. So I get these guys. So let's do negative 2 squared is negative 4, so that's negative 12, that's minus 4, so negative 16, minus 7 is negative 30. 23 divided by 2 is y equals negative 11.5. Okay? So keep going. Negative 1. Plug in negative 1. Negative 1 squared is positive 1 times 3 is 3. Negative 2 plus 3 is 1 minus 7 is negative 6 minus 2 is negative 3. Okay? Plug in 0. So the square root of 0, 3 times 0 is 0. 2 times 0 is 0, so it's negative 7 divided by 2 is negative 3.5. Okay, now I have my little parameters and I have this guy. Now, do any of my x's repeat? No. Do any of my y's repeat? No. Would it matter if my y's repeated? No, my y's can repeat, my x's cannot. So is this a function between negative 3 and 0? Yes. And I'm actually going to tell you this is always a function. You don't need to worry about that right now. So yes, this is a function between negative 3 and 0. Okay? So now that's your 3 ways. Using an equation to make your table, having the table and checking for x's repeats, and thirdly looking at the graph and seeing if it's a function. Now, I'm going to hopefully put 2 worksheets in there that are about functions and telling if something's a function. The next video is going to be about exponents, okay? Awesome. Thank you and good night.